In Chapter 12, we're going to be learning about circles. So to start, the definition of a circle is the set of all points in a plane that are equidistant from a given point, which we call the center of the circle. So we're going to use the point O for the center of that circle, so we would say this is circle O, or we could use this abbreviation right here, which says the same thing, circle O. So that definition says that every point on the circle is exactly the same distance away from that one point that we started with at the center. So when I draw those line segments, that's what a radius is. So a radius is the segment drawn from the center to a point on the circle. And then a diameter is a segment from a point on the circle to another point on the circle, but it has to go through the center. So if you're looking at my picture here, I've drawn both of those things. So this radius right here, starting at point O, going over to the circle, this segment right here in red, that would be a radius, which I'll call R. When I drew all the way from this point on the outside of the circle to this point on the outside of the circle, but I made sure that it went through the center of that circle, this would be a diameter in blue that I'm going to call D. I'm sure we're familiar with these terms. We have to make sure we cover all the basic terminology with circles. And then, like all shapes, congruent circles would be circles that have the same radius, which forces them to be the exact same circle because they're the exact same size and exact same shape. So naturally we have a theorem. If a radius is from the center of a circle to a point on the circle, then naturally every radius of that circle is congruent to every other radius that you could draw. And this is very simple to understand because if from O to C is a certain distance, O to A is the exact same distance because I came from the same center to a point on the circle. So every time you have a circle, you could mark that those two segments are congruent. Very important theorem, usually used in proofs, simple idea to understand. Another definition we have is a chord. A chord is a segment that has its endpoints on the circle. But the difference between a chord and a diameter is a chord does not have to go through the center of the circle. So if you look at the circle down here, we have point E and point F on the circle. And when I connect them inside the circle, just this segment inside the circle would be the chord. So I would call this chord EF, which we could just say segment EF because it's like any other segment, just happens to be in a circle. If I say the word secant, a secant is a line that intersects the circle in 2 points. So when I'm talking about a secant, we're actually talking about the entire line. So if this line was line M, this would be a secant because it's a line that goes all the way through the circle. Very nitpicky, I know, but those are two different things when we talk about vocabulary. A tangent line, not to be confused with sine, cosine, and tangent. When we're talking circles, a tangent is a line in a plane of a circle that intersects the circle only at one point exactly. So point P on this circle would be my point of tangency, and the line, let's call it line L, would be the line of tangency or the tangent line.